Hello CloudPedagogians, welcome back to the course. In the previous session, we have learned AWS Fargate, which is serverless compute. In today's session, we will learn about another serverless compute, which is AWS Lambda. We will first learn what is AWS Lambda, then we will learn about how Lambda works. Next, we will walk through with AWS Lambda function handler. So, what is AWS Lambda? AWS Lambda is one of the serverless compute options you have available to you on AWS. If you want to deploy your workloads and applications without having to manage any EC2 instances or containers, you can use AWS Lambda. Lambda allows you to package and upload your code to the Lambda service, creating what's called a Lambda function. AWS Lambda lets you run code without provisioning or managing servers or containers. So you can run code for virtually any type of application or backend service, including data processing, real-time stream processing, machine learning, WebSocket, IoT backends, mobile backends, and web apps like your student directory application. AWS Lambda requires zero administration from the user. You upload your source code and Lambda takes care of everything required to run and scale your code with high availability. There are no servers to manage, bringing you continuous scaling with sub-second metering and consistent performance. How does actually Lambda works? There are three primary components of a Lambda function: the code, configuration, and trigger. The code is source code that describes what the Lambda function should run. This code can be authored in three ways. You can create the code from scratch. You can use a blueprint that AWS provides. And finally, you can use same code from the AWS Serverless Application Repository, a resource that contains sample applications such as Hello World code, image resizing code, video coding, and many more. When you create your Lambda function, you create the runtime you want your code to run in. There are built-in runtimes such as Python, Node.js, Ruby, Go, Java, .NET Core, or you can implement your Lambda functions to run on a custom runtime. Next, the configuration of a Lambda function consists of information that describes how the function should run. In the configuration, you specify network placement, environment variables, memory, invocation type, permission sets, and other configurations. Finally, the triggers describe when the Lambda function should run. A trigger integrates your Lambda function with other AWS services, enabling you to run your Lambda function in response to certain API calls that occur in your AWS account. This makes you quicker to respond to events in your console without having to perform manual actions. All you need to do is what, how, and when of your Lambda function to have functional compute capacity that runs only when you need it to. I mean, once you create a Lambda function, it's not always running all the time. Instead, Lambda functions run in response to triggers. You configure a trigger for when you want your function to run, and from there, the Lambda service waits for the trigger. There is a long list of available triggers for AWS Lambda. I won't run through all of them right now. However, a couple of common examples of triggers for Lambda functions are an HTTP request, an upload of a file to the storage service, Amazon S3, events originating from other AWS services, or even in-app activity from mobile devices. When the trigger is detected, the code is automatically run in a managed environment. An environment you don't need to worry too much about because it is automatically scalable, highly available, and all of the maintenance of the environment itself is done by AWS. You do, however, get to choose the language your Lambda function is coded in. the amount of memory and CPU your function is allocated in the environment, its permissions, dependencies, and many other aspects of how the function runs. If you have 1 or 1,000 incoming triggers, AWS Lambda will scale your function to meet demand, each in its own isolated environment. Lambda is currently designed to run code that has a runtime of under 15 minutes. So this isn't a long running processes like deep learning or batch jobs. You wouldn't host something like a WordPress site on AWS Lambda. It's more suited for quick processing, like a web backend for handling requests or a backend report processing service. One of the best things about Lambda is that you aren't billed for the code that isn't running. You only get billed for the resources that you use, down to 100 milliseconds intervals. Let's understand AWS Lambda function handlers. The AWS Lambda function handler is the method in your function code that processes events. When your function is invoked, Lambda runs the handler method. When the handler exists or returns a response, it becomes available to handle another event. Here you can use the code snippet when creating a function handler in Python. In the naming section, the Lambda function handler name specified at the time you create a Lambda function is derived in two ways. The name of the file in which the Lambda handler function is located, the name of Python handler function. A function handler can be any name. However, the default on the Lambda console is Lambda function.Lambda handler. This name reflects the function name as Lambda handler and the file where the handler code is stored in Lambda function.py. If you choose a different name for your function handler on the Lambda console, you must update the name on the runtime settings pane. When you look at the billing granularity, AWS Lambda lets you run code without provisioning or managing servers. And you pay only for what you use. You are charged for the number of times your code is triggered, in the form of requests, and for the time your code executes, rounded up to the nearest 1 millisecond duration. AWS rounds up duration to the nearest millisecond with no minimum execution time. With this pricing, it can be very cost effective to run functions whose execution time is very low, such as functions with durations under 100 ms or low latency APIs. Also, there is now more of an incentive to optimize the duration of functions even if it is already well below 100 ms. Your engineering efforts can reduce costs even more. That means that increasing performance and reducing latency is going to be cheaper than before. Well, I think that's all for today's session. But I hope to be back soon. Until then, have fun.